On the Chapter 5 test review sheet, I'm going to make this video for problems 9 and 10, came from the same section, and your directions are telling you to solve these equations by using either factoring or by using taking square roots. Okay, so number 9, we're going to have to use solving by taking square roots because we cannot factor the sum of two perfect square terms. So to solve by taking square roots, we're going to isolate x, which means I need to subtract 144 from both sides. So my first move is going to give me this. So to solve for x at this point, the way I solve for x given x squared is I do the square root. And if I do the square root of the left side, of course, I must also do the square root of the right. And once again, just trying to help you with the typical mistakes that students make. Maybe you can benefit and not repeat those mistakes. Most people get half of the credit for these solutions because they fail to remember that solving a quadratic equation involves obtaining two solutions. Remember, the degree of the polynomial, in this case it's a second degree, should tell you how many solutions you should be solving for. All right, so I should end up with two solutions. If I don't include plus minus, I'm only going to end up with one solution. Okay, the positive. So the square root of x squared is just x. And I'm going to have plus minus, so I've got two solutions, one positive, one negative. And now I need to simplify the square root of negative 144. Remember, the way we simplify negatives now that are under radicals, square roots, is using the number I. So my two solutions will be positive and negative 12i. And those are my answers for number 9. On number 10, I didn't tell you on the review sheet, on the directions, but I want you, because I just don't want you to forget it, if the box method is called for, meaning if the a term in the quadratic function is greater than 1, I want you to use the box method. I want you to show the box method. Okay, and for this particular problem, it's not that big a deal, but I just want you to be familiar with it so you can take it with you to your upper level math classes. Well, first of all, let's identify what we know about the factoring. There is no GCF, so I'm left with trying to factor this as two linear binomials multiplied together. Remember, factoring is just another way of showing this using the multiplication of two factors. Well, one thing I know about my two factors is they both have to be minus as far as the signs are concerned. Remember what minus in front of plus always means as far as the signs of your answer. So with that said, when I use my box, I'm not going to put any signs. There's no need because I've already got the signs, and that way I won't be confused. So here's the way the box method works. I put the first term and the last term diagonally across from each other. I multiply those together, and now I'm looking for the factors of 3x squared that add up to 4x. I know it says negative 4x, but remember we've already taken care of the signs, so we're just going to use 3x and x. Multiplied together, they would equal 3x squared. Added together, they would equal 4x. Now find your 4 GCFs. Find the GCF of the top row, that would be 3x. This bottom row, that would be 1. This column would be x. This column would also be 1. And that shows you what your factoring is. 3x minus 1, x minus 1. Okay, another common mistake. I will have people on the test, they will get to this point, they've done the factoring correctly, they've used the box method great, and they think, I'm done. Well, remember what solving means? Do you remember what a solution is? A solution is a number that you would replace and put in place of x that makes this true. I haven't found any number yet that I could plug in for x to make this equation equal 0. I mean, I've factored it, which is great, but I haven't solved anything at this point. So the way to come up with the solutions, when you get it in factored form, which is what we've done, just think about each of these factors individually equaling 0, and you're going to solve each one separately for x. Remember, we're looking for 2 solutions. And one of my solutions will be x equals 1/3. Comes from this factor. And the other solution will be x equals 1. So those are your complete answers for problems 9 and 10. One of them we had to use taking square roots. Don't forget plus minus, very important. The other one we used factoring, and just keep in mind that if you do have a quadratic where a is greater than 1, I do want you to show the box method in your factoring. And these are our 2 solutions. So I hope that helps. Let me know if you have any questions.